Hey there, and welcome. Today, we're diving into a super simple but really powerful tool for all you TK through second grade teachers out there. It's all about helping our students structure their thoughts so they can explain not just what they know, but how they know it. So here's our plan. We'll start with the framework itself, then break down its four main parts. We'll see it in action with a simple example, check out how it works for more complex questions, and then we'll wrap up with some practical tips you can use in your classroom right away. Okay. So as teachers of our littlest learners, we've all been there, right? You ask a question, a student's hand shoots up, they give you the perfect answer, but then you ask, how did you know that? And you just get a shrug, or maybe an I just knew. So that's the real challenge, isn't it? How can we give them the words and the structure to actually explain their thinking? How do we build that super important bridge from just knowing something to being able to explain it? Well, that's where this simple graphic organizer comes in. Seriously, it's a game changer. Think of it like a visual roadmap for their thinking. It turns the abstract process of reasoning into a concrete, step-by-step task they can actually see and follow. Okay, so let's crack this thing open and look at the four parts. Now, we're using some kind of big academic words here: question, claim, evidence, and reasoning. But trust me, they're presented in a way that's totally accessible for our youngest students. First up, you've got the question. That's our starting point. Then, students tell you their answer, which is their claim. Next, they find the proof, their evidence. And finally, they show how that proof connects back to their answer, and that's their reasoning. This whole process is scaffolded using these super simple sentence stems. The first step is just stating the claim. And that stem, I think the answer is, gives students a clear, consistent way to get their first thought out there. Next, we shift their focus to just observing. The stem, I see, is a great little prompt to get them to find real, tangible proof. It's all about grounding their ideas in what they can actually see and point to. And this right here, this is the final and honestly the most crucial link. That stem, I know this because, is where the magic really happens. It's explicitly asking them to connect the dots between their evidence and their claim, and to say that whole thought process out loud. Okay, theory is one thing, right? Let's see how this actually plays out in a real classroom. We're going to use a super common task, just identifying a shape. So here we have a finished organizer. Let's just imagine you're doing this with your class, maybe in a small group. Let's model how a student would fill this out, piece by piece. First things first, we lay out the question for everybody. The problem we're all trying to solve is, which shape has four sides? It's super clear, super focused. So a student looks at the shapes and makes their claim. And using that sentence stem, they'd say something like, I think the answer is the square. Boom. They've stated their answer clearly. Okay, so next you prompt them to find that evidence. What do you see that makes you think it's the square? And they might point out, it has four sides, or I see four corners, and maybe that the sides are all equal. They're just collecting facts they can see. And now for the big connection. We ask, okay, but how do you know it has four sides? Using that reasoning stem, the student can finally explain, I know this because I counted each side on the shape. And look what happens when you put it all together. You get this complete, well-reasoned answer. My answer is the square. I see the square has four sides. I know this because I counted each side on the shape. What a huge leap from a kid just saying the square, right? But here's the really cool part. This framework isn't just for simple stuff like identification. You can use it to tackle more complex questions, like, say, comparing two different things. So here, you can see our first example right next to a new one. The tool itself looks exactly the same, but notice how the question on the right side asks for a higher level of thinking? It just shows how beautifully this framework grows with your students. So our new question is, how are a triangle and a square different? Now, this asks students to not just look at one thing, but to analyze two things and talk about how they're related. So to answer this, the student has to find evidence for both shapes, right? They see that a triangle has three sides, and then they see a square has four sides. They're now collecting and comparing two different pieces of information. And the complete answer this framework helps them build is just so thorough. My answer is that a triangle and a square have a different number of sides. I see the triangle has three sides, and the square has four sides. I know this because I counted the sides on each shape. The result is just so precise. It's based on evidence, and it's perfectly structured. It's amazing. Okay, so you can see how powerful this is. The question now is, how do you actually bring this into your classroom in a way that feels natural and supportive for your kids? All right, here are a few really practical tips. See that word bank on the examples? Definitely use that to help scaffold key vocabulary. Model using these sentence stems out loud, all the time. A big one, start with actual physical objects, things that can hold and count, before you even move to pictures. You can also use this four-part structure to guide your class discussions, not just for written work. And finally, co-create these. Fill them out together as a whole class on the board before you ever ask students to try it on their own. This framework really just gives our youngest students the keys to unlock and explain their own thinking. It builds so much confidence and lays a foundation for critical reasoning that's going to serve them for years and years to come. So the only question left is, what's the first topic you could use this for with your students this week?